This is not the shock out of the 749. It is out of a 749, just not my 749. So, when I was going through the bike, I decided the shock looked a little bit tired. It functions perfectly well from what I can tell, but the body looks decidedly scruffy. So I went on eBay and I found a second-hand shock that in the photos looked really nice, because in the photos it had been taken from this side and it mostly looks quite clean, and I thought for less than £100 I'd take a punt and buy it. And then it turned up and of course it's not really any better than the shock I've already got. So that'll teach me for cutting corners. So what I'm going to do now is I'm going to take this one apart. I'm going to get the spring powder coated, the body replated and give it a refurb inside. And then this one can go in the bike and the other one can come out of the bike. The advantage to having two shock absorbers is I can leave one in the bike so the bike is sort of easy to move around once I get to the point I've put wheels back in it. And then I can just swap this shock out with the other one, and then I can either refurb the other one or just sell it on. So I need to take this one apart. So the first step is to take the spring off the shock, and to do that you need a spring compressor. I jack that up down there. It pushes the shock body up. This collet comes loose, and then once I have two hands free I can whip the collet out and then the spring's loose. Easy as that, when you have the tools. I've already found a bit of a problem. I've taken the spring off, and this is sort of the position where you can actually test if the shock is working, because you can push the shock down, the shaft down, and the gas pressure in here should push the shaft back up. But it doesn't. It just stays there. And even as I push it down, I can feel there's a bit of oil at that point, but this section here, you can hear that the body is either full of gas or it's full of air, and it's certainly not full of the oil it should be full of. So this is knackered. Or at least it is, but then I'm going to take it apart anyway. So what I shall do is I shall continue to take it apart and see what's knackered inside. And hopefully, with the service, it'll be as good as new. Fingers crossed. To make the shock safe to work on, I need to release the gas pressure from the canister. Now this is particularly easy on this because it's got a Schrader valve on it, and I'm guessing there's not a lot of pressure in it anyway. So, wasn't a lot of pressure in there, and if I press that down, it pushes the sort of piston or the bladder in a little bit, gets rid of any gas at all. And then what I'm actually going to do is take the valve core out of it, because we don't need that in anymore and it'll make life easier later. So now I know there is no gas in there, so there is no pressure, it is safe to take the rest of the shock apart. So I need to take this sort of end plate, which in effect is just sort of a dust cover, off the body of the shock, and I need to take the end off here, extend the shaft like that, and then I can get into this, tap the cover out of the way, and then I can get into the sort of the seal head, push that down, flick the O-ring out, the circlip out, and pull the whole piston out. Right, I can tell two things straight away from getting the piston out. The oil level is too low. The oil level is about here in the shock and it should be higher. And the oil stinks because it's been in there quite a long time and I'd imagine has done quite a lot of work. So now I've got the cover plate off, we can see in here we don't have a bladder, we have a floating piston. So this piston floats against the oil, and it'll have oil on the bottom side, nitrogen on the top side, and it's got seals and a piston ring on it, so it will slide up and down. Basically, as the shaft of the shock goes in, it has to displace some fluid, because obviously the shaft itself is taking up some space, and the difference is taken up in the floating piston down here. And it helps keep the pressure on the oil so it doesn't cavitate as easily. So we can pour the oil away now, and then we need to get that floating piston out. It'll be easier for me to get the floating piston out of there when I've got this body off, because then I can just pop an airline on that and fire it out that way. So I need to take the body off because this bit needs to go away and get replated anyway. So the trick is going to be, I've got to clamp that end in the vise and then warm this up with a blowtorch until it's a little bit loose, and then I should be able to twist this off there. Or at least that's the idea. So that's the shock all in pieces. The sort of the body came out of the head quite easily. I just warmed that up a little bit with a blowtorch, didn't have to get particularly hot, and then just spun that off because it's on the same thread as the preload rings. So that was pretty easy, and then I just put an airline in that hole there, and that pushes the floating piston out. So the plan from here is to give this a bit of a clean up, so we've got rid of any of the sort of corrosion marks and bits on it, and send that for replating so it comes back looking new. And then I will rebuild the seal head, get new seals for all the floating piston and the ends and everything, put a new piston ring on it, on the piston here, and then put it all back together, and it should look and work as new. There's been a little bit of a variation from the original plan. When I separated the shock body, I gave it a lovely clean to make sure it was in reasonable condition and not too corroded before I sent it for plating. And it actually came up that nicely that I haven't needed to get it plated. So that has saved a few quid. Right, I have a rebuild kit, a service kit from K-tech. I have all the bits clean in front of me, but what I need to do first is finish stripping the piston down to clean up all the shim stack and change the seals in the seal head. Okay then, maybe I'll do the seal head second. What I'm actually going to do first is screw the body back onto the top, because then it gives the sealant a little bit of a chance to go off before I start throwing oil near anything. So with the body and the top rebuilt, it's time to do the shaft and the seal head. Now this is the important bit, because this bit's got all the shims and bits on it that actually do all the damping. So it's kind of critical that we get this bit right. So stripping this assembly down is relatively straightforward. I undo the nut, which I've already loosened, and then I'm going to take all of the bits off in order and lay them down on my sheet of paper. So we now have a shaft with no shims on it, but you can see here a little hole. Now that is a bypass hole that runs from there up the inside of the shaft and goes down there. And this is attached to the rebound adjuster, which is round the other side of here. So basically there's a little gear in there, so when I wind the adjuster screw in or out, it winds a shaft up and down in here and pushes a bypass hole open or closed. Now this is the rebound adjuster actually out of a completely different shock, but you get the idea. This pushes up or down and it blocks off a hole in here. Or when you open the rebound adjuster, it moves down and opens the hole in the adjuster. So what that does is basically lets more or less oil through the bypass, and sort of, it bypasses the entire shim stack, so you can move more oil before you open your shim stack, which basically gives you more or less damping. So these are all the shims from the shim stack. Now this is the really important bit, this is the piston. So this bit with the big holes in it, this is obviously attached to the shaft, and as the shaft goes up and down, the piston with the shims on it pushes against the oil, and the oil has to go through either the bypass in the shaft we've just talked about or through these holes. But these holes are covered up by the shims. So these are the rebound side shims, so they sit on there, and at the point where it can't flow any more oil through the bypass hole in the shaft, it has to open these shims up. So basically it flexes the shim to the side and allows oil to pass through. And obviously the more shims you have, or the stiffer the shims, the more damping you have. Now interesting, these you've got two big shims and then you've got a little shim, and that's called a crossover shim. So what you can get in effect is quite soft damping early on, so these move a little bit, but when they move just enough that they've crossed over this shim, then they hit the rest of the shims, and then if you want the rest of the shims to open, then obviously you need more pressure. So in effect you've got the bypass down the shaft, and then you've got your easy to move shims, and then you've got your harder to move shims. So it all sort of makes sense that, as you're bouncing around a slowly undulating road, the oil can pass through the shaft quite easily. You hit a bit of a bump and it'll open up these shims. If you hit a really, really big bump, it opens those, which then in transfer goes over the crossover and opens all of these shims up, and you get more oil flow. I say hitting a bump. These are the rebound side ones, these are the compression, but you get the idea, that's how they work. So what we need to do is make sure all of this stuff is lovely and clean, and at the moment it isn't. There's actually quite a lot of dirt on everything, and that's basically where the old oil has gone off, and you'll have a little bit of carryover from O-rings, the piston ring and bits like that. So what we need to do is make sure everything is spotlessly clean, put some new seals in the seal head, and then pop it all back together. Right, then I have my seal head rebuilt with new seals and a new bush in it, so that can go on the shaft. So I have my seal bullet so that I don't damage the seals as I'm pushing on, and I've got a little bit of lube in there and in the hole because, well, everybody likes a nicely lubricated hole, don't they? So that slides down there, and there we go. That is the seal head refitted. So what I need to do now is, one by one, clean these and slide them back onto the shaft. So I have the compression shim stack refitted. When people talk about revalving, what they're doing is either changing the arrangement or the thickness of the shims, or they're changing the piston, or both possibly, because that obviously alters the characteristics of how hard it is to open the shims, therefore how much damping you get. The other interesting thing to look at is the design of the piston. So looking at the piston, you can see we have 3 holes there and then these bigger, more open holes. So if I put this rebound shim over here, it covers the 3 little holes, but it doesn't cover the outsides of the big holes. And basically what this is for is, when you're in compression, the oil will flow straight past the rebound stack, go through these holes, and push the compression stack open that's against these holes out here. And then, in effect, that shim is acting as a non-return valve and stopping any fluid going through these holes. And then obviously when we're in rebound, these holes are closed by the compression stack, and so these holes are flowing all the oil, and so if you want to flow any oil through it, you're going to have to bend the shim out of the way. So that's how that works. It's also quite important to make sure we fit this the right way round, and that is with this side up. Now I have the shaft and the seal head and the shim stack and piston all rebuilt, it's time to start putting stuff together. But there's one last bit of damping that we need to address. Because the bypass hole that runs down here and goes to the rebound adjuster opens up across the entire shim stack, it does actually affect compression and rebound. It just happens to have more effect on the rebound, so we always call it the rebound adjuster. But there is a compression adjuster as well. On the body, there is a compression adjuster up here. Of course, how does that adjust compression if the shim stack is on the piston? Well, that's where this little bit comes in. This is literally just a compression shim on its own, and that sits in this part of the body. So when the oil is getting pushed up here in compression, some of it will go through the shim stack, and some of it, of course, is going to come through here and into the chamber up here. This only works one way, and in effect, in the cap here, there is another little sort of bypass adjuster, a little taper, and that will close or open the hole in here, which will let more or less oil through past this shim. And this shim isn't actually a shim stack, it's literally just a non-return valve that I can't get to with my fingernail. But that is literally just a non-return valve that basically gives a tiny little bit of compression control, but really it's not doing that much. So when it comes to adjusting, the rebound adjuster will make a lot more difference than this compression adjuster. So with the shock body rebuilt, the next thing to do is start pouring some oil, and I'm going to be using Motul shock oil. I now have the chamber mostly full of oil and the shock body mostly full of oil, and I've just popped the floating piston in. Now I don't need to set the final position of this just yet, that will come later. So the next thing I need to do is fit my shaft into my hole. So relatively straightforward. I'm going to pop this in here, give it a little bit of a wiggle. You'll see the oil coming out through the bypass already, and I just need to push that into there. And as I work that up and down a few times, hopefully all of the air bubbles will come out of it. But again, it's not to the end of the world if it doesn't get all the air out just yet, because there is going to be another trick later. So I've been stroking this up and down by hand, as dodgy as that sounds, and I've got most of the air bubbles out of it. So the next thing to do is to push the seal head into the body and get the circlip back in it. So the seal head is fitted, the circlip is in, so the shock is basically sealed. But there are two slight issues with that. There's still a tiny little bit of air in it because the other side of the piston has a recess in it, which is slightly annoying, and there might just be a tiny little bit of air still trapped in the system. It's always hard to tell. So I need to bleed the last little bit up and set the floating piston position. Now a lot of shocks actually have a bleeding point, so you can put a vacuum bleeder on them. These were clearly never designed to be taken apart and serviced, but there is of course a way around it. Instead of a specific bleed point, there is of course the compression adjuster, which I can take out, and that will allow me to move any air that's left in the system up to the highest point, and it'll allow me to set the floating piston position. So obviously I'm going to get quite a lot of oil back out of the hole in a bit when I set the piston position, but it doesn't matter because it'll all dribble into the sink, which is not connected to the drain, it's just connected to a bucket. So that is the plan. Take this back out, see how much air we've got in the system. Quite a lot, to be fair, because this doesn't take up that much room, so that has filled quite a bit of that void with air. So what I'm going to do now is I'm going to move the floating piston up ever so slightly by hand, so it fills this area up here with oil, and then I can move the piston ever so slowly from the other end and see if it pushes any air out of the hole. There we go, look. Getting a little bit of air out of there. So I shall just do this a few times until we're definitely not getting any more air out, and then I can set the piston position and refit the compression adjuster. We are nearing the final stages now. I've refitted the compression shim stack and I've moved it around a little bit with a pair of pliers, and I've also forced the shims open to get rid of any air that's trapped underneath that, so that's clear. There's no air when I pump the main shaft up and down anymore, and that's that pushed all the way in. So the last thing to do is to set the floating piston position in here. Now I don't actually have the exact data from this shock because when I got it, it was full of air, which isn't particularly useful, but I do have measurements for Ohlins and Shower and bits like that, which use a similar size chamber. So basically what I'm going to do is estimate it using some information I already have. I've nearly finished rebuilding the damper unit. The only thing really left to do now is gas it up. So I have a little adapter with a good quality pressure gauge on it. So all I'm going to do is connect my nitrogen supply up to that and pump it up to lots of pressure. So I have the requisite pressure showing on the gauge, and now if I push down on the shaft, which takes quite a lot of effort, see we get a nice pushback from the gas pressure, and it doesn't feel like there's any air in there because everything moves pretty solidly. If there was a load of air in it, you'd get a load of sort of spongy movement first. But that feels very positive. Now I have the shock back together, I can give you a little demonstration on how much difference the adjusters make. Now the adjusters are working on the low speed range, so they'll have more effect with me pushing here than they would do necessarily when you're riding, because when you're riding the wheel is moving up and down faster, especially over bumps, and that's when the shim stack really plays. But this gives you an idea of how much adjustment this makes. So at the moment I have all of the adjusters wound all the way in, so the shock is as hard as it can be. And if I put, frankly, all of my body weight on it, you can see how slowly it's moving. And then when I let go, it pretty much doesn't return. But if I open this, you can see now we're getting into the range where the shock is moving. So if I open that quite a lot, and then push it again, you can see that's made a difference in the compression and the rebound. So with that quite open so we can get a reasonable amount of movement, if I now open up the compression adjuster, let's see how much difference that seems to make. So that's the compression adjuster all the way open. Maybe makes a little bit of difference. We'll close it all the way off again. A small difference, but nowhere near as much adjustment as the rebound, and this is why that adjuster's really important. With the spring refitted, which is exactly the same process as taking it off, that is it. We now have a complete, refurbished, considerably cleaner looking shock to go back in the back of the 749.